Hi guys, this is Unit 8. We're going to talk about quadratics in Unit 8, and we're going to start with Lesson 1, which is quadratics in real life. So let's talk about the form first. In the past, you learned that the linear equation is a linear equation that has 1 as the highest exponent. And the form for the linear equation is y equals mx plus b. Today you're going to learn that quadratic equations are equations with no variable raised to a power greater than 2. That means that the highest power in the quadratic equation has to be 2. And the standard form for the quadratic equation is y equals ax squared plus bx plus c, where a is not a 0 and a, b, c are real numbers. So you're going to see quadratics as expressions. Like let's take an example: 2x squared plus 5x minus 2. Or you're going to see it as an equation in 2 variables: y equals 2x squared plus 5x minus 2. Or you're going to see it as a function where we have f of x equals 2x squared plus 5x minus 2. Now in this example, a, b, and c are real numbers. A is equal to 2, that's the leading coefficient in this quadratic. B is the coefficient of x, which is in this case 5, and c is the constant, or the last number in the equation, which is negative 2. Now let's talk about the graphs of quadratics. We know that the graphs of linear equations are just lines on the grid, and the graphs of the quadratic equations are a U-shaped graph called parabolas. And when the leading coefficient is positive in the equation, the parabola opens up. That's a U-shaped parabola. It opens up. That's when the A is positive. Positive makes a smiley face, which means the parabola is up. And then if the leading coefficient is negative, that means that the parabola is up and down, which makes a frowny face. Now let's talk about the properties of quadratic equations, or quadratics in general. The first thing we're going to talk about is the vertex. And the vertex is the lowest point of the parabola when the parabola opens up. So in this parabola, we have a minimum, and the vertex is the minimum point. Or it could be the highest power of the parabola if the parabola opens down. So if the parabola opens down, that means we have a maximum, and the maximum point is the vertex for this parabola. We're going to also talk about the axis of symmetry, which is the vertical line that passes through the vertex and divide the parabola into 2 symmetric parts. Now, since it's a vertical line, that means it has an equation. And the equation for the axis of symmetry has a formula, which is x equals negative b over 2a. Another property are the intercepts. We have x-intercepts that are called roots, solutions, zeros. So we have 4 different names for the same thing. X-intercept, it's where the parabola crosses the x-axis. Now, quadratic equations might have no zeros, no x-intercepts, 1 intercept, or 2 intercepts, 2 x-intercepts. So this is an example of a parabola that has no zeros or no x-intercepts. So in this case, we have zero roots, 0 zeros, or 0 solutions. Or no solutions, not 0 solutions, but no solutions. Now, this is an example of a parabola that has 1 solution because the parabola crossed the x-axis at 1 point. And in this case, the parabola has 1 solution, or 1 zero, or 1 root, or 1 x-intercept. And this is another example where the parabola has 2 roots, 2 solutions, 2 x-intercepts. So a parabola can have no solutions, 1 solution, or 2 solutions. And we also have dy intercept, which is the c value in the quadratic equation, where the parabola crosses the y-axis. Now let's take a look at this graph. This parabola belongs to the quadratic equation x squared plus 4x minus 5. If we look at this parabola, we will see that it has 2 roots, or 2 solutions for x. We have x equals 1 and x equals negative 5. It also has a y-intercept at negative 5. The parabola also has a minimum, since the leading coefficient in here is a positive. So we have a minimum point, and the minimum in this case is negative 9, and the vertex is negative 2, negative 9. Now, the axis of symmetry is the vertical line that goes through the vertex and divide the parabola into 2 symmetric parts. And as you can see, we have the vertical line here in the middle. Now, the equation for this vertical line follows the formula x equals b over negative 2a. Now, if we look at this equation, we'll find out that a equals 1, b equals 4, a equals 1, b equals 4, and c equals negative 5. Which means that the equation for the axis of symmetry is x equals 4 over negative 2 times 1. And we know that negative 2 times 1 is negative 2, which means we're going to end up with x equals negative 2. And this is the equation for the axis of symmetry.